Major version upgrades are one of the scariest operations in Postgres. The old PG upgrade approach typically requires downtime, and while it's fast, rolling back requires restoring from a backup if something goes wrong.
So what's the alternative?
Logical replication. You stand up the new version alongside the old one, replicate data in real time, validate everything works, then cut over traffic. If there's a problem, you can switch back to the old cluster, though you'll need to carefully handle any changes made during the cutover period. Let's walk through the entire pattern step by step. There are 5 major phases, and we'll cover the tricky bits that catch people out.
I'm ready. Where do we start?
Logical replication lets you run both versions in parallel. The old cluster keeps serving production traffic, while the new one replicates changes in real time. You're not locked into a one-way migration.
So if we discover a problem on the new version, we can revert to the old one?
Yes, but any changes made on the new version won't automatically sync back. That's why you need to catch issues quickly during validation, or set up bidirectional replication using additional tools if you want a longer rollback window. The old cluster is still the source of truth until you decide to cut over. Here's the full pattern. First, you stand up a new cluster running the target Postgres version and restore your schema. Then you set up logical replication from old to new and let it sync. Phase 3 is monitoring. You watch replication lag, validate data, and test queries on the new cluster.
And the cutover happens in phase 4?
Right. You freeze DDL changes, let replication catch up completely, sync your sequences, then switch your application connection strings to the new cluster. But you keep the old cluster running and maintain a recovery strategy so you can handle any issues. That's phase 5. Let's get into the mechanics. Setting up logical replication correctly is critical, and there are a few gotchas.
What's the first step on the source cluster?
On the source cluster, wall level must be set to logical. The default is replica, which supports physical replication but not logical. You'll need to alter system and restart Postgres if it's not already logical. Note that alter system changes the setting globally for the entire instance.
So this is one of the settings that requires a restart?
Yes, wall level changes typically require a restart. Plan for a brief maintenance window to make this change if you haven't already. Once that's done, you create a publication on the source for the tables you want to replicate. On the source, you create a publication. This defines what gets replicated. For all tables is common, but you can list specific tables if needed. Then on the target cluster, you create a subscription pointing to the source and referencing that publication.
And that kicks off the initial data sync?
Exactly. The subscription will do a full table copy first, then switch to streaming changes. You can monitor progress by querying pg-stat subscription on the target, watch the state column until it shows streaming for the subscription. Here's a critical point. Logical replication only streams row changes, inserts, updates, deletes. It does not replicate DDL. If you alter table or create index on the source, that change won't automatically appear on the target.
So we have to apply schema changes manually to both sides?
Yes, and that's why we enforce a DDL freeze before cutover. During the replication phase, any schema change must be applied to both clusters manually in the same order. Sequences are another gotcha. Their current values don't replicate either, so you have to sync them separately right before cutover. Once replication is running, you need to validate that the new cluster is actually ready. This phase is where you catch problems before they become outages.
What should we be checking?
First, confirm replication lag is consistently near 0, query pg-stat replication, and look at the lag columns. If lag is growing, you have a throughput problem. Next, compare row counts on critical tables between old and new. They should match exactly once replication catches up.
And we should test actual queries on the new cluster, right?
Absolutely. Run your critical queries against the new version and check performance. The query planner can behave differently across major versions, so an upgrade from Postgres 12 to 15 might change plans. Also verify that all extensions and custom functions work. Some extensions need updates for new major versions. Run this query on the source to see replication lag. Write lag is how far behind the subscriber is in writing changes, flush lag is how far behind in flushing changes to disk, and replay lag is how far behind in applying changes. All should be under a second in a healthy setup. Note that these lag columns are available in Postgres 10 and later.
What if lag is consistently high?
High lag means the target can't keep up with the source's write rate. Common causes are undersized target hardware, missing indexes that exist on the source, or replication configuration issues. You need to fix that before cutover, or the new cluster will fall behind immediately. By the way, my DBA's free health check monitors replication lag continuously, flags inactive or lost replication slots, and provides guidance on managing subscriptions. It's built for exactly this kind of migration scenario.
That sounds way easier than manually querying pgstat replication every hour.
Now we're at the cutover itself. This is the most delicate phase. You're switching production traffic to the new cluster. Let's break it down step by step.
What's the very first thing we do?
Step 1 is announcing a DDL freeze, no schema changes from this point forward. Then you wait for replication lag to hit 0 and stay there for a few minutes. Next comes the critical step, syncing sequences. Logical replication doesn't replicate sequence values, so you have to manually copy the last value of every sequence from source to target.
How do we do that without causing gaps or collisions?
You query the source for each sequence's last value, then on the target you run setVal to set it to that same value or higher. Do this right before switching connection strings so the window is tiny. Then you update your application config or DNS to point to the new cluster and immediately start monitoring error rates and query performance. Here's the sequence sync in action. On the source, you grab last value from each sequence. Then on the target, you call setVal with that value. The third parameter, true, means the next call to nextVal will return the next value after the one set by setVal. If set to false, nextVal would return the value set by setVal.
And we do this for every sequence in the database?
Yes, every sequence that's used by your tables. You can script this by querying information schema or PG class to get the list, then loop through them. The entire sync should take seconds if you automate it. The DDL freeze is non-negotiable. If someone runs an alter table on the source after you validated the target schema, you'll have a mismatch and replication can break or the cutover will fail. The freeze usually lasts 15 to 30 minutes, just long enough to sync sequences and switch traffic.
How do we enforce it? Just tell everyone not to deploy.
Communication is key. Announce the freeze window in advance. Some teams also revoke DDL permissions temporarily or use a deployment lock in their C/CD pipeline. The goal is to make it impossible to accidentally run a migration during the cutover. Even with perfect preparation, you need a rollback plan. With logical replication, the old cluster is still there, but switching back may involve more than just changing connection strings. You need to ensure data consistency and reconfigure replication settings as needed.
So what does a proper rollback look like?
There are two rollback scenarios. Immediate rollback is when you discover a critical issue within minutes of cutover. You point connection strings back to the old cluster. The old cluster can be kept current with logical replication or similar setup, allowing it to receive changes up until cutover.
What if we need to roll back hours later?
That's the extended rollback window. To support this, you can set up reverse replication using additional tools, from the new cluster back to the old one, right after cutover. Then if you need to roll back 6 hours later, the old cluster has been kept in sync, and you can switch back with minimal data loss. You typically maintain this for 24 to 48 hours, then tear it down once you're confident. The most common issue is query performance regression. The new Postgres version might choose different plans, and a query that was fast on version 12 could be slow on 15. That's why you test critical queries during validation. Extension incompatibility is another one. An old version of PostGIS or pgvector might not work on the new Postgres version.
And connection pooling?
Connection pool settings that worked fine on the old cluster might not on the new one. especially if you changed hardware or tuned max connections differently. Watch for connection exhaustion or statement timeout errors immediately after cutover. If you see any of these, roll back, fix the issue, and try again. After cutover, you're not done yet. Monitor the new cluster closely for at least 24 hours. Watch CPU, memory, disk I/O, query times, and error rates. Ensure you have a rollback strategy, such as maintaining backups or using reverse replication to handle any subtle issues. Once you're confident, usually after 48 hours, you can drop the replication slots and subscriptions.
And then we can finally shut down the old cluster?
Yes, but take a final backup of the old cluster first, just in case. Then decommission it. Don't forget to update your documentation and run books with the new version number, any configuration changes, and lessons learned from the migration. Future you will thank you. If you're planning a major version upgrade, my DBA's free health check will give you a head start. Connect your database, and you'll get a comprehensive report across 16 domains: replication health, query performance, configuration tuning, and more. It's free, it takes a few minutes to set up, and the report keeps updating every week as it learns your workload.
Where do we sign up?
Head to my dba.dev and connect your database. You'll have your first health check in minutes, and it gets deeper over the first week. Good luck with your upgrade.